Okay, excellent. Thank you. And in case you're confused by the change in the title, it's the same thing. You're not in the wrong talk. So I'd like to talk to you today about architecting for scale and simplicity. And the way I think about this is we often talk a lot about architecting for scale, but not so much actually about the other side, about making sure things are simple, things are resource efficient. And I'd like to sort of explore this topic with you today and talk through things. Now, I'm Viktor, and I work for Personio, and I'll sort of like to go through things in roughly this order. So I'll start off with an intro. I'll tell you a bit about myself, and then I'll sort of try and dive into the problem landscape. You know, what does it mean? What do we even mean by scale? And how do we do this, build services that scale but are also simple? Maybe we'll talk about what simple means, actually. And then we'll go through some anecdotal examples. Granted, these were sort of carefully curated by me, but each one is selected to basically talk about a particular facet of the issue. And then I'll share with you some of my tips for building, for architecting for scale, whilst thinking about simplicity. And then we'll kind of summarize. Yeah, so I'm Viktor, work for Personio, and Personio, as we've all heard, we build payroll solutions. Previously, we started off building kind of a core HR product, and in the last few years, we started out building this payroll solution. And you can kind of imagine this because payroll on the other side, we've built with sort of a monolithic mindset in mind. You know, it's been our bread and butter for so many years. And then we started building in this new world where we have the sort of microservices. And in between these two systems, you have a pipe gluing things together, basically streaming data as events over onto the other side. Well, I love chess. Any chess players here? Okay, just a few. That's all right. I'll make do with that. So yeah, and I live in rural Cambridgeshire. Very, very nice place to be. I think that's stock photo, but looks quite like where I live, not on the farm. And as we talked about, Personio, we started in Germany, but now sort of expanding through Europe and covering the United States fairly recently as well. So, why do we care? Why do we care about architecting for scale and simplicity? Well, as I mentioned earlier, in my experience, I've sort of been involved in doing a lot of what I call failed architectures. Anyone here with similar experiences, building stuff that didn't work or didn't scale? Excellent. Now, this is good company. And I've sort of done that, and many times I've taken a step back and say, you know, what made this work? Why did it fail? I remember one particular experience where we sort of built this system. It was built over many, many, many years. And we stored literally everything in a database. It had code, it had data, it had UI fragments, and we even used the database as a message queue. Sounds familiar? Oh, only a few people have done that. Well, it worked for a while, and it got the company off the ground. We got stuff done. But as you can imagine, over time, no one understood how the system worked. I think at one point we had something like 500,000 lines of stored procedures. So we never look at it. It would probably work. And how do you test it? Well, we deploy to the customer, and then they tell us if it works. and that was how, to be fair, a lot of people actually did their testing. It just didn't care. But also, we've done the same thing with distributed systems. With distributed systems, we've basically just distributed the confusion to multiple services. And I remember doing this with some very early incarnations of sort of what we now call distributed services. Anyone used OSGI? OSGI gave us views. Okay, if you have a high pain threshold, that's the framework to use. it is basically services coming and going in a single JVM. Very nice in theory, but very, very, very painful in practice. So you can see that wherever you go, whether it's with monoliths, whether it's with distributed systems, you can still run into this problem where architecting for scale and simplicity is very difficult to do. And that's kind of really the background to my talk. This is why I want to talk about this. Well, what is this talk not about? Well, it's not about this tech is better than that tech, or, distributed services are better than monolith, or, those sort of things. I think we all have opinions on those things. And those opinions, I think, are usually quite valid in different scenarios. But I think for me, it's more about actually going back to the fundamentals and asking the basic questions. Is this solving my problem? Is this working? Is this best practice the best thing to do in this situation? So let's go back and look at the problem landscape. What does that look like? So someone comes to you and say, build a scalable system to do X. And by X, I don't mean Twitter, but X variable. So build Hacker News, build something. And then we go away, do a design doc, and then do some back of the envelope calculations and do various things. And we come up with something like that. And don't worry if you can't see the details. It's just a client going over DNS, getting some IP address. If you're fetching some static assets, you go talk to a CDN, which might fetch what you need from an object store. Otherwise, you go via load balancer, which will direct you to some web server, probably a reverse proxy somewhere there. Depending on whether you're doing a read or a write, and depending on whether your write is synchronous or asynchronous, you might go down different paths. And eventually, you would hit the data store and get what you need. And once we've done this, we then go on and start to build the system. And I think this is part of where the problem actually starts, because if you think about it, what's the scaled down version of this? Actually, there isn't a scaled down version. You might be able to reduce most things here to single instance, when you're not experiencing traffic. But you still need one each of everything on this diagram. Otherwise, it doesn't work. You can't just do away with your database, So you need everything on there in order for it to work. And we actually noticed this also in our work at Personio, because we build a payroll solution. Payroll tends to do most of their work in a certain period of the month. But for the rest of the month, you have this whole infrastructure just sitting there, and you're paying Amazon or whoever you're using for your cloud storage a lot of money. So we sort of started to think about, how could we make things better? But the other problem with this is that you're actually making assumptions about what kind of scaling you need and how your system, might actually scale. You don't know that actually up front. And we'll see with some of the examples we'll go through that actually it's not always obvious, even when you think it is, how things might scale. But then also take a step back. How would you test this? You just start in the project. You've got this technical, nice architecture. How would you test it? It is actually super hard to test something like this end to end. So all of that is basically captured in this made-up graph that I've drawn. Building a scalable system to do X, often what we try to do from the get-go is to build a system with a very high baseline cost. Before we're even able to prove correctness, we've built a system that costs a lot to start with, costs a lot to run, and costs a lot to actually verify that it actually does what you want it to do. So it's a significant, irreducible overhead that you start off with. And as I mentioned earlier, the system may well scale up, but doesn't scale down. And that's very important because scale doesn't mean magnify. Scale means that you're able to adjust, this way and that way, depending on maybe how many users you have and so on. But the other thing I find important to mention here is that for scale, complexity is also important because you need to bring new team members on, they need to spin up, and the more moving parts you have, the longer it takes for people to wrap their heads around how stuff works. So why do we do it? Why do we do this? Why do we build these systems this way? I have some theories, and some of them may be slightly controversial, but I think maybe some of you would probably recognize some of them. I think we do it sometimes because it's the cool thing to do. There's some fancy new tech. We're just going to use it. What will it do? We don't know. We're just going to use it. And so we use it. Or what's company X doing? What's Google doing? And whilst it's great to look at some of those companies, but usually they're solving problems at quite a different scale than we sometimes are. Yeah. But another thing, I think, is it's great for promotion. No one gets paid to solve simple problems. In most instances, a lot of companies where I've worked in the past, you see this trend that simple solutions are like, People don't think about solutions in terms of what impact did it make. They think about solutions sometimes in terms of, how complicated is it? And that's probably something for maybe the managers in the group to sometimes think about. But sometimes also people say we are an XYZ shop. This is how we do stuff. This is how we build stuff. And that's what you've got to use. So that's another reason. Now, the one reason I want to really, really drill into is this other one, design interviews. Because I love design interviews, but I also really don't like them. And I think they are actually underpinning some of the problems that we see here. Why do I hate design interviews so much? Well, that's what they look like. And usually when people look at that, you make a number of false assumptions about them. One of the false assumptions people make is that what you come up with there is a starting point. That this is what you start off building. But the problem with that, as we mentioned earlier, is once you start off with that, it is very, very difficult to do anything else. Very difficult to test, very difficult to prove correctness, and so on. And one of the things I like to say to people is it is much easier to scale a correct system than to correct a scaled system. Because the level of entropy in a scaled system is so high that you really, really struggle to understand what's going on. If you have a cache somewhere in your architecture, you have to be really worried because suddenly things become very difficult to test. A cache you might get the cache hit, you might not. How do you prove what happened? And suddenly the things that actually help you to scale can also be hindrances and can slow you down. So with design interviews, you're not expected to be frugal. You tick off as many things as you can on that list. You need heavy rights access, throw in Cassandra. It costs nothing. It's just a few boxes on the chat. And so people go do some fancy stuff and you get through the interviews, which is great. But also sometimes I think we don't really have a good sense of what scale means. How much RAM do you need to hold the complete works of Shakespeare? Anyone know? 1 meg? 1 meg? Any other yes? 10 meg. 10 meg? Okay. These are great engineers here. 5 meg, roughly. Thereabout. But when I think about it, complete works of Shakespeare is about that size. The first time I thought about this, I thought this will be several gigabytes. It's a lot of information. But actually, it's not. It shows how sometimes, as humans, our estimates can be way off the mark. So, looking at some of those false assumptions, we assume that we can scale automatically if we use all these things. We assume that, we start off with those designs. But we also have a few other things that we sort of think about. We think this tech is slow. And this database is, I've had this experience before where we say, oh, well, if you want speed, use Dynamo, not Postgres. But you then discover that if you're going to get the performance out of Dynamo, you need to know how your access patterns are going to look like. But actually, for every database, if you know your access patterns, if you know what they're going to look like, they will be fast because you will optimize for that to start with. So what you find is whatever tech you use is giving you something, but is also taking something away from you. Now, just to balance things up, I'm not saying, go in this other direction. As we've mentioned before, we've all built big monoliths or worked with one, and we know the pain that's associated with it. And that's definitely not the direction we should be going in. So what I would like to do now is to run very quickly through some examples, anecdotal examples of how people have built systems. And then we can sort of try and pick a thing or two from each of those examples. The first one, Stack Overflow. Fairly simple setup, single deployment, single artifact deployment. Now, what I must mention with some of these is companies don't often share what their current architecture looks like in detail. So some of these may be out of date. If you work for Stack Overflow or any of these companies, do let me know if this is high fidelity or, if it's anything close to what you now run. I will be super interested. But yeah, simple layout. Anyone looking at that understands. Imagine if you get a new team member. This makes sense straight away. Okay. And with that, they're able to handle, roughly 30 million plus searches per day. Now, obviously, this doesn't show you what's inside the box, but it kind of gives you an indication of what they're trying to aim for, the sort of simplicity they're aiming for. Shopify that I mentioned there, and for what I gather, they are fairly simple, fairly similar, and they handle even way more scale than Stack Overflow works. And what I found interesting with Shopify in particular is it's fairly sort of monolithic setup in Ruby. And if you work with Ruby in large code bases, you know that can be a really tricky thing to do. But to do that and still do somewhere in the region of 1 million RPS shows that some really great engineering can be done regardless of the deployment layout that you choose. And then Hacker News. Go back to my original statement. Design a scalable system X. If someone said to you, design Hacker News, would you imagine that what you would come up with deploys on one box? But that is really what architecting for scale and simplicity looks like. It is lowering the initial overhead so much that you're able to see solutions that are simpler than what you would have ended up with if you started, with sort of a high overhead. Another one, and this one is actually quite interesting because it's fairly new, and a lot of people in the audience will probably know about it. And what Prime Video did here was, and this was their monitoring service, not Prime Video itself. This was the thing that they used to do quality analysis on videos. And what they did here was they built a bunch of stuff, came up with the architecture, as usual, perhaps did their back of the envelope calculations. And essentially, what they came up with was a bunch of lambdas shuffling data about between themselves. What they discovered in reality was that they wouldn't get beyond 5% of their scaling target. That shows you how wrong you can be when you do your calculations and when you go into the real world. And then they decided to go back to the drawing board, do things again, and they came up with that, which is actually kind of a mirror image of what they'd done before, except things were now happening in process. So the same components, the same sort of architecture, but instead of shuffling data over the network, they decided to shuffle data in process using a shared memory space. And this worked much better for them. I think they had a 90% reduction in cost in this way. I won't spend too much time on this. I included it just for fun. Just seeing levels FYI using Google Sheets as backend. And it shows you how far people are willing to push this. And you push it and you realize it still works. And as a counterexample, Netflix. And we all know Netflix does have a fairly sophisticated architecture. In fact, I think the box there with microservices there is actually literally hundreds of microservices. But it does work. However, think about it. Netflix is roughly 20% global internet traffic. You're not talking about, tiny service, serving 4 million requests per second, 4 million requests per day. This is a huge entity. So, putting all of this together very quickly, my advice, generally when you're building a scalable system, is start simple. Prioritize simplicity. Focus on proving correctness first before you start to scale. Stay in process where you can. Minimize the mismatch between the problem space and the solution domain. And what I mean by that is what is simple should be simple, and what is complex should be complex. Avoid complications. And this is especially important when you make sure that both your failure modes and your happy paths are properly represented in your models. Because one of the problems people run into is the happy path is fine. But if you have a 2% failure rate and those 2% failures have to be resolved manually, your system simply won't scale if you need human beings to resolve 2% of it. Invest in end-to-end tests. This is something we've learned at Personio. It's something we're investing very heavily on now. In fact, I'm working on a project focusing on this, because without the end-to-end tests, the next step that I'm going to talk about will be hard to do, which is staying simple. A lot of people start simple, but find it very difficult to stay simple. And if you want to stay simple, you need one critical ingredient, which is you need allocated time to constantly refactor and improve your stuff. People do it differently. Companies like Intel in the old days used to do the TikTok cycle. Other companies allocate a constant overhead, through the project where they sort of try and maintain stuff. But you can't get around it. You need that time and headspace really to carry on improving your stuff. Now, be data-led. Use the data coming out of your system to inform your scaling investments. Don't make assumptions about this part would scale and that part wouldn't scale. Actually, look at what the data is telling you. And then understand the trade-offs. I think the way I like to put this one is there are no zero-cost abstractions in large systems. Anything that you deploy, whether you use them or not, you will pay for it. And you will pay for it in complexity, you will pay for it in hosting costs, and you'll pay for it in so many other ways. But also, it's realizing that in many cases, physics will hold you back. I think I looked at the latency numbers for that every programmer should know, and discovered that the numbers actually haven't changed very much for round trip for a packet from California to Netherlands in the last 20 years. So there are some problems that are really, really difficult to solve. And then data will hold you back. Of all this stuff you will deal with, data is the one where you really, really, really need to focus on, because that's the one with the greatest potential to actually slow you down. I included this thing about eventual consistency because a lot of people say, my database has eventual consistency. Well, it's not something you want. It's something you sort of get if you couldn't get immediate consistency. So, takeaways. Well, understand where best practices best apply. Know that you need best conditions in order to use best practices the way they are. Prove correctness before you prove scale. Focus on scaling the parts of your system just in time using the data that's coming out of your system. Maximize the amount of work not done, but also maximize the impact of the work that gets done. And then ask why. Why are we doing this? Would this really work? And after that, ask why not. Because if you take anything away from this talk, it's be skeptical, interrogate the system, and let that data lead you wherever it goes. Thanks for coming, and I really enjoyed talking to you.